So this week I'll try to explain what we are trying to achieve by feed rate optimization and how we can improve cycle time. So here is a standard corner radius end mill. As you can see from here, the feed rates are not optimized. So you've got an approach feed rate, impact feed rate, and fluting feed rates. Now what we are trying to do is eliminate all of them. That's what we are trying to do. So based on that, when I do a simulation, you can see here now it's coming at rapid, and then it goes into the approach feed rate, and then into the impact feed rate, and then it's continuing at that feed rate for throughout the fluting process, where in fact actually the material removal is much less here, and as it goes more into the flute, the material removal is more. So what feed rate optimization does is it's giving you an option to do all, which means air and grinding both, or you can do air only and grinding only. Now if I do all, and what happens is sometimes in finishing operations like primary relief, etc., you want to do air only, and grinding you want to go at a particular feed rate. We have the maximum air feed rate, so, and we have a minimum gap, and we also have the maximum feed rate which it can go up to, which you can actually, it's a user input, and we have the Q prime values and the aggression factor. And next week I'll show you how we set up this completely to achieve better results.